Hello students, in this lecture we'll cover relative motion of the particle. So first we understand what way relative motion is different from absolute motion. The motion of the particle with respect to a fixed frame of reference is called as absolute motion of the particle. Example, like motion of the train with respect to platform. Here platform is fixed in position, train is in motion. So motion of the particle with respect to fixed reference, that is called as absolute motion. Whereas motion of the particle with respect to moving frame of reference is called as relative motion, like motion of train P with respect to another moving train P. Now, to understand the concepts of relative motion between two particles, I have considered here two particles A and B, which are moving in a plane. Here I have considered X or Y is a fixed frame of reference. I am considering moving frame of reference is with A as origin, that is X, A, Y dash. Now, at any instant, absolute position of A will be a vector originating from O towards A. Absolute position of B will be a vector originating from O towards B. What will be relative position of B with respect to A? So A is moving frame of reference. So it's a vector originating from A towards B. So this way we complete a triangle. With law of triangle, RB is equal to RA plus RBA. So what will be RBA will be equal to RB minus RA, where RB is absolute position of particle B, right? RA is absolute position of particle A. RBA is relative position of B with respect to A. If you differentiate this expression with respect to T, you get VABA. Velocity of B with respect to A is VB minus VA. VB is absolute velocity of particle B. VA is absolute velocity of particle A. VBA is the relative velocity of particle B with respect to A. Differentiate this expression 2 with respect to T, you get it acceleration of B with respect to A is equal to AB minus A. AB is absolute acceleration of B. A is absolute acceleration of A. AB is what? Relative acceleration of particle B with respect to A. So you will use these expressions. And normally when if motion of the two particles is in one direction, so then we can directly get the relative position, velocity or acceleration. But if they are moving in different directions in the plane, then we have to take the help of vectors to find the relative position or relative velocity or relative acceleration of one particle with respect to other. Now we come to start with the problems. So we come across first problem. A train moving at 36 kmph is hit by a stone thrown at right angle to it with a velocity of 18 kmph. Find the velocity and direction with which the stone appears to the person traveling in the train. So that means he wants to find out velocity of the stone as it appears to a person sitting in the train means with respect to train. So velocity of stone with respect to train is required. So velocity of train is 36 upon 3.6, that is 10 meter per second. He has not mentioned in which direction train is moving. I'm assuming that it is moving towards right. Stone is thrown perpendicular to it with 18 kmph. So 18 upon 3.6, 5 meter per second. So it is perpendicular to it. I'm assuming this way. If we assume these directions, which are satisfying the given data in the problem. So we write velocity of train and velocity of stone in vectorial form. Velocity of train is plus 10I because it is in positive x direction, right? So plus 10I. Whereas velocity of stone in vectorial form is plus 5j. It is in positive y direction. So now velocity of stone with respect to train is Vs minus V. Vs is 5j minus 10I. So finally minus 10I plus 5j. All right. Now you want to find its magnitude and direction. Minus 10 means it is 10 meter per second to the left. 5j means 5 meter per second upward. VST will be then resultant velocity of stone with respect to train. VST is 10 square plus 5 square root of it, 11.18 meter per second. 10 theta is 5 upon 10, theta is 26.56. So this way we got velocity of a stone as it appears to the person sitting in the train. So this is your answer. Okay, move to the next sum. Two trains leave a station in direction at the same instant. Train A travels at 360 kmph at 10 degree west of north. 10 degree west of north means it is toward west from north at 10 degree as shown in this one. So velocity of A is 360 kmph. I divide by 3.6, so it becomes 100 meter per second. While train B travels at 450 kmph at 60 degree east of north. Right? Train B travels at 450 kmph at 60 degree east of north. This is 60 degree towards east from the north. That is 450 upon 3.6. That is 125 meter per second. All right. He is asking you to find out relative velocity of train A with respect to B. Two trains are how much apart 2 minutes later. So velocity of train A and train B are to be expressed in vectorial form now. Now its component in x direction. Minus, it will be 100 sine 10. It will be to the left, so negative. 100 cos 10 upward, that is positive. So I'll write velocity of train A in vectorial form. 100 sine 10, since it is to the left, is negative. Minus 100 sine 10 I. 100 cos 10 in positive y direction. 100 cos 10 j. So on your simplification, you get it like this. Now velocity of train B in vectorial form. 125 sine 60 to the right, I, plus 125 cos 60, j. So you get it like this. Velocity of train A with respect to B, VA bar minus VB bar. So if you do VA bar minus VB bar, it comes out to be like this. But minus 125.61 I plus 35.98. Now we have to find the magnitude and direction of velocity of train A with respect to train B. So as its I coefficient is negative, that means it is to the left. Y coefficient is positive, means it is upward. So we have shown them in the correct directions. At the same time, we understand this is north direction and this is west direction. All right, as per the north, south, east sign convention. Velocity of A with respect to B is square root of 35.98 square plus 125.61 square. So 130.66 meter per second. Tan theta is 35.98 upon 125.61. Theta is 15.98. So velocity of A with respect to B is 130.66 meter per second at west angle theta 15.98 degree north. Now we have understood that as velocity of the two trains are constant, their relative velocity will also be constant. So relative position displacement or relative position will be relative velocity into time. All right, as a relative motion is at constant velocity. So that is 130.66 into time. That is 2 into 60. What is that? 15.68 into 10 raised to 3. So this is the distance. Two trains are this much distance apart 2 minutes later. Now, next problem number 3. Now this problem is going to be of relative motion at constant acceleration. Let's understand. Each boat begins from the rest at point O and heads in the direction shown at the same instant. If A has an acceleration of 0.6 meter per second square and B has an acceleration of 0.9 meter per second square, determine the speed of boat A with respect to boat B at the instant they become 240 meter apart. How long this will take? Now this is O's origin. This is boat A is going at acceleration, which is the 30 degree with the y-axis. This is at 45 degree acceleration of A. Now we can resolve them and put them in vector form. Acceleration of A is 0.6. So 0.6 sine 30 is to the left, right? So minus 0.6 sine 30 I. 0.6 cos 30 up, that is positive in y direction, plus 0.6 cos 30. So you get it minus 0.3 I plus 0.52. Now acceleration of B is 0.9. So 0.9 cos 45 I plus 0.9 sine 45 J. You will get it. Acceleration of A with respect to B is AA minus AB. If you do AA minus AB, it comes minus 0.936 I plus 0.116 J. Now, acceleration of A with respect to B, we find magnitude and the direction. Show them. I coefficient is negative, that means to the left. J coefficient negative, that means down. So you got acceleration of A with respect to B. The square root of 0.936 square plus 0.116 square root of 0.943 meter per second square. Tan theta is 0.116 upon 0.96. You get the value of theta 7.067. That means relative motion is at angle theta, like this. As relative motion of A with respect to B is at constant acceleration, equations of motion can be applied. See that UAB will be 0. Initial velocity of A with respect to B is 0. You want to find velocity of A with respect to B when the two boats are 240 meter apart. That means displacement of A with respect to B is given to you as 240 meter. What time these two boats take to reach this relative displacement, and what is their velocity at that instant? So first we write v square is equal to u square plus 2s. But we are applying relative motion. So all terms are a with respect to c. So this is v square a with respect to is equal to u square a with respect to plus 2a with respect to plus into s a with UAB is 0 plus 2 times of AB is 0.943 into 240. Velocity of A with respect to 21.27 meter per second. It is an angle theta with horizontal as shown. This is going to be along the same direction in which you have the relative motion at constant acceleration. V is equal to U plus AT, VAB is equal to UAB plus AAB into T. VAB is 21.27, UAB is 0. Acceleration of A with respect to 0.943 into T. You get T as 22.557. All right. So here that comparison between this problem and the previous problem. In the previous problem, relative motion was at constant velocity. Here, relative motion is at constant acceleration. Now here we will be having a problem which involves the concepts of projectile also, along with relative motion. A jet of water is discharged at A with a velocity of 20 meters per second to strike a moving plate B as shown. If the plate is moving downward with a velocity of 1 meter per second, determine the relative velocity of water with respect to plate just before it strikes. It is a tank, sort of, from which the water jet is coming out with a velocity of 20 meters per second horizontally. At 6 meters away, there is a plate which is going down with 1 meter per second. As jet of water is like motion of projectile, it is thrown horizontally. So vertical component of the velocity of the water jet initially will be 0. All right. So here at the instant when the water jet just touches the plate, we assume that its velocity components are Vx and Vy. All right. Now we'll consider motion from A to B of the water jet. All right. Motion of water jet from A to B. Now 6 is equal to horizontal displacement is horizontal component of the velocity into time. 6 is 20 into t. So you got t is 0.3. Now, vertical component velocity, v is equal to u plus at, vy, u is initial vertical velocity 0, plus 9.81 into 0.3, 2.943 meter per second. X component of the velocity at b will remain same, 20 meter per second. You know that during projectile motion, horizontal component of velocity remains same. Now, at point B. Velocity of water is 20I minus 2.9 minus 2.943 y. 20 is horizontal component velocity at B, which is horizontally towards right, so positive. Y component velocity is vertically down, so it will be minus. All right. Velocity of plate is constant, that is 1 meter per second in negative y direction. So I'll write minus 1. So velocity of water with respect to plate is Vw bar minus Vp bar. So it comes 20I minus 1.9430. Now we have to find magnitude and direction of Vw. Or x I coefficient is positive, that means to the right. J coefficient negative, that means it is downward. So this is velocity of water with respect to plate. Velocity of water with respect to plate is square root of 20 square plus 1.943 square, that is 20.094 meter per second. Tan theta is 1.943 upon 20, that is theta is 5.55. So this way we found velocity of water with respect to plate at the instant when the jet of water just hits the plate or just before it is hitting the plate. So here relative motion concepts were clubbed with projectile motion concepts. Now this is a little lengthy sum. This also involves the motion of the cyclist in 2 observations. That's interesting. When a cyclist is riding west at 20 km per hour, he finds a rain meeting an angle of 45 degrees with the vertical as shown in figure A. When he rides at 12 km per hour, he meets the rain at an angle of 30 degrees with the vertical as shown in figure B. Find the magnitude and direction of absolute velocity of rain. Now here, see, motion is between rain and the cyclist. If you see that 2 cases of observation are there. In one case, when the cyclist is riding east at 20 km, he finds the rain is meeting him at 45. When he rides at 12 km per hour towards west, then he finds the rain meeting at 30. Now, here motion of the cyclist is completely defined in both cases. Relative motion is partly defined, magnitude is not given, angle is given. So motion of the rain is completely indefined. So let's say that let x and y be the horizontal and vertical components of absolute velocity of rain. So velocity of rain is xi plus y, right? So velocity of cyclist is, in the first case, we are taking it up case 1 for observation. It is 20 kmph towards left. I'll write 20 upon 3.6, that is 5.56 meter per second. So we write velocity of cyclist in vectorial form, since it is in the negative x direction, minus 5.56 I. Velocity of the rain, as we understood x, we assume that x and y are the horizontal vertical components of absolute velocity of rain. So velocity of rain in vectorial form will be xi plus y. So velocity of rain with respect to cyclist is Vr minus Vc. So Vr minus Vc x plus 5.56 I plus y. But from the given diagram, we can write VRC, velocity of rain with respect to cyclist, in vectorial form like this: VRC sine 45 I minus VRC cos 45 G. Equation number 1 and 2 are to be equated. So I and J coefficients are to be equated. So VRC sine 45 is equal to x plus 5.56 and J coefficient minus VRC cos 45 is equal to y. Now here VRC can be eliminated if you divide 3 by 4. Dividing 3 by equation 4, minus 1045 is equal to x plus 5.56 upon y. 1045 is 1, so x plus y is minus 5.56. So this is the analysis of case A, or first case of observation. All right. Now second case is to be analyzed identically. In the second case, velocity of cyclist is 12 km per hour to the left, 12 upon 3.33 meter per second. So velocity of the cyclist in vectorial form will be minus 3.3 I. Velocity of the cyclist with the velocity of the rain with respect to cyclist is Vr minus Vc dash. This is x plus 3.33 I plus y. But from the given diagram, VRC dash is equal to VRC dash sine 30 I minus VRC cos 30 J. Equate these two equations 5 and 6. You get it. The VRC dash sine 30 is equal to x plus 3.33. VRC cos 30, VRC dash cos 30 is y. Again, you can divide, so V dash RC will get cancelled. Minus 1060 is equal to x plus 3.33 upon y. So it comes out to x plus 0.57 y is equal to minus 3.3. Now we have got two equations in terms of x and y. This is equation number A, this is equation number B. Solving A and B, you get the value of x and y. X is negative 0.288 meter per second, y is negative 5.22 meter per second. X and y are the horizontal and vertical components of absolute velocity of rain. So x is negative means to the left, y is negative means downward. So this is going to be the resultant velocity of rain, right? Velocity of rain will be 0.288 square plus 5.272 square root of that. That is 5.279 meter per second. All right. If you have to convert into kmph, multiply by 3.6, that comes around 19 kmph. All right. Tan theta is 5.727. Sorry, 5.272 upon 0.28a. You get theta as 86.87. Now you need to, as he has given the data in terms of north, south, east, west, you have to give the answer also in the same terms. So you can understand this is west direction, this is south direction. So we can say velocity of rain is 19 kmph at west angle theta as south. So theta is 86.87. So velocity of rain is 19 kmph at west 86.87 degrees. So this way we arrive at the absolute velocity of rain from the analysis of two observations of the motion between rain and the cyclist. Now we have come to the next problem, problem number 6. Figure below shows cars A and B at a distance of 35 meters. Car A moves with a constant speed of 36 kmph and car B starts from rest with an acceleration of 1.5 meter per second. Determine relative position, velocity and acceleration of car B with respect to car A 5 seconds after car A crosses the intersection. Student, this diagram is given. In the beginning, at t is equal to 0, car A is at the center of intersection. Car B is 35 meters away. Car B is coming from a road which is meeting a straight road at some angle. So that angle has been defined by 345 right angle triangle. So what we assume that, let's assume that center of intersection be the origin to reference axis. This is required for writing the position vectors. So initially, this is origin. Car A is at this point initially, right? this distance car B is this is initial position of car B, this is initial position of car A. All right. This is this direction of car B is defined by 3, 4, 5 right angle triangle. So we can say that tan theta is 4 by 3, cos theta is 3 by 5, sin theta is 4 by 5. Is that all understood to everybody? Now, now we first analyze the motion of car A. Car A is moving towards right with the 36 kmph. So 36 upon 3.6, 10 meter per second, and it's constant. At t is equal to 5 seconds, as the velocity of car A is constant, so acceleration of car A will be 0. Velocity of car A is 10 meter per second towards right, and it covers the distance of, as motion is at constant velocity, distance covered by car A is 10 into 5, 50 meter. Now we'll write acceleration of A, velocity of A, and position of car A at t is equal to 5 seconds in vectoral form. Acceleration of car in vectoral form is 0. Velocity of car A is plus 10i, and position of car A in vectoral form is plus 50i. Because it is in first quadrant, it is right of origin at 50 meters. So plus 50i. We should remember that position vector of particle is written with respect to origin. It has nothing to do with the direction of the motion. See, direction of motion is needed for writing velocity and acceleration in vectoral form. But for writing the position vector, we look at the position with respect to origin. It does not depend upon direction of motion of the particle. So A is initial position at the center intersection. A dash is final position of car A, 50 meter right of origin. Now car B. Car B starts from rest 35 meter away from the center intersection. U0. Acceleration of car B is 1.5 meter per second square at angle theta. Theta is defined by 3, 4, 5 right angle triangle. All right. At t is equal to 5 seconds, we write v is equal to u plus ab. Vv is equal to 0 plus 1.5 to 5, 7.5 meter per second at angle theta. S is equal to ut plus half it square. This is the distance covered by car B in 5 seconds. Initial velocity is 0 plus half into acceleration of A is 1.5 into t square, 18.75. So you can see that from this diagram, initially car B was 35 meter away from the origin along this line. Then it covered in 5 seconds, 18.75 meters. So that means it is still 16.25 meter away from the origin, but along this direction. All right. So now you can write acceleration of B. You have to simply resolve this acceleration. So that is what is going to be minus 1.5 cos theta I minus 1.5 sin theta j. Cos theta, sin theta values can be substituted. Cos theta is 3 by 5, sin theta is 4 by 5. So cos theta is 0.6 and sin theta is 0.8. Velocity of car B can be written in vector form. So that is here minus 7.5 cos theta right, minus 7.5 sin theta j. Substitute the value of cos theta and sin theta, you get the velocity of car B vector. Now, position of car B. Position of car B, it is in first quadrant, so its two components will be positive. X component will be 16.25 cos theta and Y component 16.25 sin theta. So, absolute position of car B will be plus 16.25 cos theta I plus 16.25 sin theta j. So that cos theta sin theta value substitute, you get it 9.75 I plus 13. So then position of B with respect to A is RB bar minus RA bar. So that comes out to be minus 40.25 I plus 13 in meters. Velocity of car B with respect to A in vectoral form VB minus VA. So that if you substitute VB and VA values, you get it minus 42.25 I plus 30 J. Velocity of B with respect to A is minus 14.5 I minus 6 J in meter per second. Acceleration of car B with respect to is AB minus A. So that comes out to be, substitute the value of AB and A. A is in fact 0. So whatever is AB bar, same becomes the acceleration of B with respect to A minus 0.9 I minus 1.2 J meter per second square. This way, we have got relative position of B with respect to A, relative velocity of B with respect to A, relative acceleration of B with respect, but in vectoral form. If it is needed in the examination, we can find the magnitude and directions also. So with this, students, I have covered. This is my last video. As far as my subject is concerned, I have uploaded videos of all the topics given in my book or all the topics of mechanics subject. All right. For anything, any query, you can always contact me on my mobile number given on the book, and the mail ID is also given in the book. Right. I request once again to share the QR code of my YouTube channel with your friends so that they are also benefited. Yes, of course, if you buy the book, it will be again beneficial because many more solved problems are given in the book. All right. Some practice problems, MCQs are also given. All right. Book can be purchased from the Amazon, or it is also available on the local bookstores also. All right, friends. Thank you very much. All the best to you all.